Hi, in this video we are going to solve minimum pluses question. If you haven't solved this question before, please give it a try by yourself. I recommend this to you. Okay, before jumping on to the solution, you have to try with yourself with your own logics. Okay, after that you can come to the tutorials. Okay, so let's get started, and I'm going to read the question statement first. Given a equation x equal to y, for example 111 is equal to 12, you need to add pluses inside x, which is this part, okay, to make the equation correct. In our example 111 is equal to 112, we can add 1 plus 1 plus 1 is equal to 12 and the equation becomes correct. You need to find the minimum number of pluses to add x to make the equation correct. If you cannot find the answer, you can print -1 here. So what are the constraints here? That this y won't be exceed 5000, so its limit is 5000. Okay, and this a the total length of this string will be 10 to the power 3. Okay, so this problem actually consists of many sub problems. So we are going to solve first smaller one, then we will go to the main solution of it. Okay, so the first problem arises that the given input is a string and we need to separate out the x and y. Okay, so let me just go to my OneNote. Okay, suppose there is given that 1 1 1 is equal to 1 2. Okay, 1 2. Now we will get this as a string in the in our input. We will get this whole as a string. Okay, and these are the index numbers. Okay, so what we are going to do, we are going to make a string x and store these positions here, and we are going to make an integer y, and we will store 4 5 positions, that means respective to this question 1 2, which is 12 in y. Okay, then we are going to solve this question. Okay, so before jumping on to the solution, we have to take care of the input, how we can take care of that. Okay, so we have taken out the input here. So what the question is actually saying is, suppose there is given that 1 2 3 4 and 5 is equal to 2 3 4 and 6. We need to make this equation correct. How we can make it? We can add plus in between of this string. Okay, so we can add one anywhere, one or more than one plus that we can add. We can add plus a plus here or here or here or here, anywhere we can. Or not only one, we can add 2 pluses or 3 pluses, many pluses here, n-1 pluses actually. If this length is n, then we can add actually n-1 pluses, because suppose its length is 5. Okay, then we can add only 4 pluses here. Okay, at max. Now we are going to see what is the solution and how we can get this 2 3 4 6 by adding plus in between here. Okay, now suppose I have 1 2 3 4 5. Now if we have take 1 plus here, then what will be the output? The output will be 1 2 3 and 9. Okay, so is it equal to this or not? It is not. Then this is the wrong answer. Okay, or we can do that 1 plus 2 3 4 and 5. Then what will be the output of it? It will be 2 3 4 and 6. So if it is equal to this or not, so these are equal, then this one is correct. Okay, So what we have done, that we have add 1 plus in between 1 and 2 3 4 5 here. Okay, so we have got our answer. So this is what the question is saying actually. Okay, now let me just give you the brief introduction how you can firstly separate the input. Okay, firstly take the perfect output. Okay, because when we see in the here in the sample test there is not given. Okay, there is only C, a string is given, we need to separate it out by ourselves. Okay, now I will show you how you can separate out this. Okay, so this is the this is our code. I have solved this, and we will just simply take string as input. Suppose this is a string which is we have taken in the our example 1 2 3 4 5 is equal to 2 3 4 6. Okay, now we have taken this as a string. Okay, now what we will do, we will just start the ith I from 0, which is from here, from this 1 to this 5. Okay, and this 5 is occurring before this equal to. Okay, so now we will just iterate the I till we will find equal to. Okay, so we have done that, and we will just take a string x1 and take the substring of x from 0 to I, from 0, that means 1, to 5. Okay, from 0 to here, from to equal to, because if we take equal to then we will get this. Okay, so we have taken out the input, which is 1 2 3 4 5 into x, and we will just store the I plus 1 from I plus 1, that means I is now here 5. From 6 we can 2 3 4 6 we can take it as integer. So now I have taken I have used stoy function, which represent string integer. Okay, it converts the string to integer. So from I plus 1 to n minus 1, from I plus 1 to n minus 1, I have taken out the string and converted it into the integer. Okay, so this is our input. Then we have taken our answer is equal to minimum plus x1, we have passed the first string x, the y, and the starting position from where we are going to solve this question, that I will explain it to you afterwards. This is our, and this question, this will solve our question fully. Okay, so this is the code. Now I'm going to show you how you can exactly solve this question, what is the logic behind it, and how you can solve it. Okay, so this is our string x and this is our string y. Okay, now I have made an algorithm which take this x as x as input, in which x will in which my function will simply call 4 recursive calls. Okay, and each recursive call, they will first start from here. Okay, from 1. Okay, from 1, then it will start from 2, second call, then then third call will start from 3, and fourth call will start from 4. Okay, now why only fourth call? The reason behind it you will get afterwards. Okay, so from first call I will just take 1 as it is, then add 1 plus. Okay, only 1 as it is, then 1 plus. Okay, then after that 2 3 4 5, write it as it is. Okay, 2 3 4 and 5. Now you can see that 2 3 4 5 is also a sub problem which needs to be divided. Okay, so we will divide it also. So from 2 3 4 5, suppose I will write it here clearly. 1 plus 2 3 4 5. Okay, now 2 3 4 5 is also a problem in itself. Okay, so from 2 3 4 5 we will also call 4 calls. Okay, from 2, okay, from 3, from 4, and from 5 as well. Okay, now from 2, 1 is already written here. Okay, so we will write it as it is, 1 plus 2, then again plus, then what will remain, 3 4 5. Okay, then 3 4 5. Okay, now we will again 3 4 5, we will go to 3 4 5. Okay, now it is also a problem, then we will call 4 calls, but here is only 3 numbers, so we can call only 3 calls. Okay, so from 3 we are going to go for 1 plus 2 plus 3 plus 4 5. Okay, plus 4 5. Now, and 4 5 is also a problem. Now from it will go to 4 and 5 as well. We will get back to here afterwards. Okay, now for 4 5 it is also a sub problem, then we will divide it into 2 function calls, then it will be 1 plus 2 plus 3 plus 4 plus 5. Okay, then from 5 we can also call, then we will get back here afterwards. Okay, now what we will do, we will just simply add these, then what is the result of it? Okay, what is the result of it? It is 1 plus 2 3 6 10 and 15. It is 15. So is it equal to this or not, 2 3 4 6? Is it equal to 2 3 4 6 or not? No, it is not. So we will not consider it, we will go backwards. Then after that, okay, then after that what we will do, we will take 1 plus 2, then plus 2 plus 3 plus, we will not take plus after 4. Okay, because we are starting from here, 5, from 5, so we will take it as it is. Okay, 45. So what is the output of this? It is 6, then it will be, its output will be 51. Okay, then 51 is not equal to is also not equal to 2 3 4 6. Then we will go backwards again, then we will go to this point. Okay, so from this point it will be what, 1 plus 2 plus 3 4 plus 5. Okay, from 3 4 plus 5. Okay, no, not 5 actually. After 3 4, yeah, after 3 4 we will put 5 actually. Okay, so what is the output of this? What will be the output of this? The output will be 1 plus 2 plus it is 6 6 plus 34 sorry, 3 plus 34 is 37, and it will be 42. It is also not equal to 2 3 4 6. Okay, so we will go backwards, then again, then we will take as it is this 1 plus 2 plus 3 plus sorry, only we will take 3 4 and 5. Okay, we will take 3 4 and 5. Now what it will give the answer, that 1 plus 2 is 3, then we will go 3 4 5 plus 3 3 4 8. Okay, so it is also not equal to this. Okay, it is also not equal to 2 3 4 6. Now what we will do, we will just so we have completed the first call of our this is this. Okay, so these are the all the functional calls that we have generated from our first call. Okay, here. Okay, now from this second call we are going to see it will also not give the correct output, because the only output the best output that will give is 1 plus 2 3 4 5, which we will get after this call, which we will get this in this call. So it will I will just directly jump to this call. Okay, so it will be 1 plus, take 2 3 4 5 as it is. Okay, 2 3 4 5 as it is. So it will give the output what, 2 3 4 and 6, and it is equal to this. Okay, so this is the our correct output, and the output is the number of the minimum pluses that we have added is 1. So 1 will be returned. Okay, so 1 is the output here. Now it will go from this this side here, from 1 to plus 3 4 5, and many calls will be generated because it is recursion. Okay, so let me just show you my recursive code of this problem. Okay, so this is our problem, this is our recursive code. We have passed x1, which is the string, this x, and y, which is the number. Okay, and 0, which is the position that we have started from 1 here. Okay, so what we are going to do, we are going to see that first of all, just ignore this. We are going to see that first of all answer will be in maximum integer we are taking, because we want a minimum answer. Okay, then we are making 4 calls. Why 4 calls and how 4 calls? Because index plus 4, we are taking only plus 4 from the current index. Current index just like is 0, so from 0 we are going to do 1 2 3 and 4 till 4. We are making the calls, as we have seen here that we are taking only 4 calls. Okay, so this is our this is our loop which are creating the 4 calls. Okay, or if the length of x, if the length is already less than 4, then we will take only this, because here we have seen that we are taking only 2 calls. Okay, not 4, because there are only 2. Okay, so that is the reason I have written here, and this intel means I am typecasting it simply. So from in the first iteration, the substring will be 1 1. Okay, so number will be 1. It is converting string. 1 is the string right now to integer. Okay, now if, and this is the simple condition, if we have reached the end, that means the 4, then we cannot actually add 1 after 5, after 4. Okay, suppose we have reached there 5, then we cannot convert, we cannot do this 2 3 4 5 plus, we cannot do this. Okay, that's why I have made it this condition, and the answer will store what, minimum of answer, current answer, which is integer max, or it is making the recursive call that x comma y minus num, negative from y minus 1. Okay, from 2 3 4 6 neglect the 1, then after call to the second. Okay, 2 3 4 2 3 4. Okay, so and it increment 1, that we have included 1 plus, in between 1 and 2. Okay, then this is our output, then we will see how it work actually. So let me just output it. Okay, so its output is correct, which is giving 1 as our output. Okay, now let me just run it. Oh, it is over. I think I have to restart it. So I'm submitting this code here. Okay, so let's see what is the output, either whether this is accepting. um, okay, so we need to exclude these spaces that we have just written here. Okay, so it is giving me correct output. Now let's just submit it. Two test cases are passed, and every test case has an timeout. Okay, so our code is working fine actually and giving us the correct output, but it is not actually that much efficient. Okay, because it is a recursive code and it is making too much of recursive calls without storing them. So what is the strategy that we have to follow here is we need to store. We are making, you can see that we are making 4 n calls, 4 की power n calls. Okay, 4 to the power n. Okay, so this will be very exponential. Okay, so we cannot use it. So what we will do, we will just store every state. Suppose this is state answer we will store, and this is state answer we will store. Every state answer that we will store in a table, and in that table, if we occur again this problem, again this sub problem that we are occur again, then we will return simply that. So we will avoid the recursive calls that are making repeatedly, same function call that are making repeatedly. Okay, so this is our this is for this video, and I hope you have understood how the code is working, and I will give you the link in my description that you can download this code. Okay, in the next video I am going to apply the dynamic programming approach, so that it is a little bit minor approach, little bit change approach, so that you can easily solve this problem in a given time constraints. Okay, we will not edit this code, we will just simply uh, do minor changes and the code will work fine. Okay, so thank you everyone, you can subscribe my channel. Okay, thank you.